First, we'll see book back exercises. Roman letter 1. Choose the correct answer. First one, a solution is a dash mixture. Answer A. Homogeneous. Second one, the number of components in a binary solution is dash. Option A. Answer 2. Third one, which of the following is the universal solvent? Answer is C. Water. Fourth one, a solution in which no more solute can be dissolved in a definite amount of solvent at a given temperature is called dash. The answer is A. Saturated solution. Fifth one, identify the non-aqueous solution. Answer is D. Sulfur in carbon disulfide. Sixth one, when pressure is increased at constant temperature, the solubility of gases in liquid is dash. Answer is B. Increases. Seventh one, solubility of NaCl in 100 ml of water is 36 gram. If 25 gram of salt is dissolved in 100 ml of water, how much more solute is required for saturation? Dash. The answer is B. 11 gram. Within a bracket 36 minus 25. Eighth one. A 25% alcohol solution means dash. Answer is C. 25 ml alcohol in 75 ml of water. Ninth one, deliquescence is due to dash. The answer is A. Strong affinity to water. Next, 10th one, which of the following is hygroscopic in nature? Dash. The answer is C. Silica gel. Choose the correct answer is over. Next, we'll see Roman letter 2, filling the blanks. First question, the component present in lesser amount in a solution is called dash. The answer is solute. Second question, example for liquid and solid type solution is dash. Answer, mercury with sodium. Third one, solubility is the amount of solute dissolved in dash gram of solvent. Answer is 100. So, solute dissolved in 100 gram of solvent. Next, fourth question, polar compounds are soluble in dash solvents. Answer is polar. So, polar compounds are soluble in polar solvents. Fifth one, volume percentage decreases with increase in temperature because dash. The answer is expansion of liquid. Okay, next we'll see Roman letter 3, match the following. First question, blue vitriol. Second, gypsum. Third one, deliquescence. Fourth one, hygroscopic. Next we'll see the answers for this. First one, blue vitriol. Answer, CuSO4 dot 5H2O This is the formula for blue vitriol. Next, gypsum. Formula CaSO4 dot 2H2O. Next, third one, deliquescence. Answer NaOH. Fourth one, hygroscopic. Answer BCAO. Okay, so match the following as over. Next, we'll move on to the Roman letter 4. True or false? If false, give the correct statement. Okay. First question. Solutions which contain 3 components are called binary solution. Answer is false. The given statement is false. So write the statement. Solutions which contains 2 components are called binary solutions. Okay. Second question. In a solution, the component which is present in lesser amount is called solvent. The answer is false. The given statement is false. So correct this statement. In a solution, the component which is present in higher amount is called solvent. Next, third one. Sodium chloride dissolved in water forms a non-aqueous solution. Answer is false. So correct the statement. Sodium chloride dissolved in water forms a aqueous solution. Next, question number 4. The molecular formula of green vitriol is MgSO4.7H2O. The statement is false. So the correct statement is molecular formula of Epsom salt is MgSO4.7H2O. Okay. Next, fifth one. When silicone gel is kept open, it absorbs moisture from the air because it is hygroscopic in nature. The answer is true. So true or false is over. Roman letter 4. Next we'll see Roman letter 5. Short answer questions. First question. Define the term solution. What's the answer? A solution is a homogeneous mixture of 2 or more substances called solution. Next, second question. What does mean by binary solution? A solution contains 2 components is called binary solution. One solute and one solvent. It's called binary solutions. Example, salt in water, sugar in water. This is the example for binary solution. Next, third question. Give an example for each. First one, gas and liquid. Second, solid and liquid. Third one, solid and solid. Fourth one, gas and gas. We'll see the example for each one. First one, gas and liquid. Example, soda, water. Second, solid in liquid. Example, sodium chloride in water. Third one, Solid in solid. Example, copper dissolved in gold. Alloys. Fourth one, gas in gas. Example, mixture of helium, O2 gases. Question number 4. What is aqueous and non-aqueous solution? Give an example. First we will see what is aqueous solution. The solution in which water acts as a solvent is called aqueous solution. The solution in which water acts as a solvent is called aqueous solution. Example, common salt in water, sugar in water. This is the example for aqueous solution. Second one, non-aqueous solution. So what is non-aqueous solution? The solution in which any liquid other than water acts as a solvent is called non-aqueous solution. Example, sulfur dissolved in carbon disulfide. Another example, iodine dissolved in CCl4, carbon tetrachloride. Next, question number 5. Define volume percentage. Volume percentage is defined as the percentage by volume of solute present in the given volume of the solution. Next you write the formula. Volume percentage is equal to volume of the solute divided by volume of the solute plus volume of the solvent into 100. Next, volume percentage is equal to, the numerator you write the same, volume of the solute divided by volume of the solution into 100. Next, question number 6. The aquatic animals live more in cold regions. Why? The answer, because more amount of dissolved oxygen is present in the water of cold regions. This shows that the solubility of oxygen in water is more at low temperature. Next, question number 7. Define hydrated salt. Answer, the number of water molecules found in the crystalline substance is called water of crystallization. Such salts are called hydrated salts. Next, question number 8. A hot saturated solution of copper sulfate forms crystals as it cools. Why? The answer is, the number of water molecules in blue vitriol is 5. So its water of crystallization is 5. When blue colored copper sulfate crystals are gently heated, it loses its 5 water molecules and becomes anhydrous copper sulfate. Then add a few drops of water or allow it to cool. The colorless anhydrous salt again turns back into blue colored hydrated salt. Next question number 9. Classify the following substances into deliquescent, hygroscopic. Here, concentrated sulfuric acid, copper sulfate, pentahydrate, silica gel, calcium chloride and gypsum salt is given. First you write it in a tabular column. First column deliquescence, second one hygroscopic. You write what are the deliquescent substance are here. Only one deliquescent substance is written here, given here, that is calcium chloride. Next for hygroscopic, here four substances are given. First one concentrated sulfuric acid is given. Formula for sulfuric acid is H2SO4. So for hygroscopic, first one concentrated H2SO4, and then second one silica gel is given. Third one copper sulfate pentahydrate. The last one is gypsum salt. Next we'll see Roman letter 6 long answer question. First question, write notes on saturated solution. First one, second one unsaturated solution. First we'll see what is saturated solution. A solution in which no more solute can be dissolved in a definite amount of the solvent at a given temperature is called saturated solution. Example, 36 gram of sodium chloride in 100 gram of water at 25 degree centigrade. Next, what is unsaturated solution? A solution is one that contains less solute than that of the saturated solution at a given temperature. Example, 10 gram or 20 gram or 30 gram of sodium chloride in 100 gram of water at 25 degree centigrade form unsaturated solution. Next, second one, write notes on various factors affecting solubility. There are three main factors which govern the solubility of solute. They are, first one, nature of the solute and solvent. Second one, temperature. Third one, pressure. We'll see one by one. First one, nature of the solute and solvent. The nature of the solute and solvent plays an important role in solubility. Although water dissolves in an enormous variety of substances, both ionic and covalent, but it does not dissolve everything. For example, common salt is a polar compound and dissolves in polar solvent like water. Non-polar compounds are soluble in non-polar solvents. For example, fat dissolved in ether. The second one, effect of temperature. Solubility of a solid solute in a liquid solvent increases with increase in temperature. In endothermic process, this solubility increases with increase in temperature. In exothermic process, this solubility decreases with increase in temperature. Next, solubility of a gas and liquid. Solubility of gases in liquid decrease with increasing temperature. Generally, water contains dissolved oxygen. When water is boiled, the solubility of oxygen in water decreases. So, oxygen escapes in the form of bubbles. Next, effect of pressure. When the pressure is increased, the solubility of a gas in liquid increases. Example, carbonated beverages. Third question, what happens when MgSO4.7H2O is heated? Write the appropriate equation. Its water of crystallization is 7. When magnesium sulfate heptahydrate crystals are gently heated, it loses 7 water molecules and becomes an anhydrous magnesium sulfate. Example, equation MgSO4.7H2O gives MgSO4 plus 7H2O. Magnesium sulfate heptahydrate after heating becomes anhydrous magnesium sulfate. Then B question, define solubility. Solubility is defined as the number of grams of solute that can be dissolved in 100 gram of a solvent to form its saturated solution at a given temperature and pressure. For example,
Happy morning, children. I am your physical science teacher. Hope you are all safe at home. I welcome you all for our today's revision class. Hope you are all received your monthly test timetable. In physics, first lesson, laws of motion, and in chemistry, lesson number 7, atoms and molecules. So, you are going to revise only those lessons, then only you will write the test properly. Okay, so for that purpose, now I am going to revise our first lesson, laws of motion. In this lesson has got choose the correct answer, fill in the blanks, true or false, assertion and reasoning, short answer questions, and answer in detail. So in today's link, let us discuss about the answers for these questions. Refer the book and write it in your notebook and submit for correction. Children, come we'll see one by one. First one, book exercise. Choose the correct answer. First one, inertia of a body depends on answer mass of the body. Second, impulse is equal to answer change of momentum. Third one, Newton's law is applicable. Answer for third one is C. Both A and B. For a body is at rest and for a body in motion. Next, plotting a graph for momentum on the x-axis and the time on y-axis. The slope of momentum time graph gives the answer is 1 by f. Fifth one, in which of the following sport the turning of effect of force used? Cycling. Answer is cycling. Next, the unit of g is meter per second square. It can be also expressed as, answer is option B, Newton kilo per kilogram. Seventh one, 1 kilogram force equal to, answer is 98 into 10 power 4 dyne. The mass of a body is measured on planet Earth as mkg. When it is taken to a planet of radius half that of the Earth, then its value will be dash kg. Option C, capital M divided by 4. Next, if the Earth shrinks to 50% of its real radius, its mass remaining the Next, we'll see fill in the blanks. First one, to produce a displacement, dash is required, forces required, answer is force. Second one, passengers lean forward when sudden brake is applied in a moving vehicle. This can be explained by dash, answer is inertia of motion. Next, by convention, the clockwise movements are taken as dash and the anti-clockwise movements are taken as dash. First one, for clockwise movement it is a negative, and for anti-clockwise movement it is taken as a positive. Fourth one, dash is used to change the speed of a car. Answer is gears. Next one, a man of mass 100 kg has a weight of dash at the surface of the earth 980 Newton. Next, we will see true or false. The linear momentum of a system of particles is always conserved. Answer is false. The reason is the linear momentum of a system of particles is always conserved only if no external forces are applied. Second question. Apparent weight of a person is always equal to his actual weight. Answer is false. Correct this statement. Apparent weight and actual weight is not equal during upward or downward motion. Third one, the weight of the bone is greater at the equator and less at the polar region. Answer is false. The reason, weight of a body is lesser at the equator and more at the polar region. Turning a net with a spanner having a short hand is so easy than one with a long hand. Answer false. Moment of a force in longer hand is easy than one with a short handle. Next one. There is no gravity in the orbiting space station around the earth, so the astronauts feel weightlessness. Answer is false. Apparent weight is zero. They are in the state of weightlessness. Next, we'll see match the following. First one, Newton's first law. Answer, stable equilibrium of a body. Newton's second law, law of force. Newton's third law, flying nature of bird. Next, law of conservation of a linear momentum. Answer, propulsion of a rocket. Next, we'll see assertion and reasoning. First one, assertion. The sum of the clockwise movement is equal to the sum of anticlockwise movement. A reason. The principle of conservation of momentum is valid if the external force on the system is zero. And B. Both the assertion and the reason are true, but the reason is not the correct explanation of the assertion. Second one, assertion. The value of G decreases as height and depth increases from the surface of the earth. Reason. G depends on the mass of the body object and the earth. The answer is C. Assertion is true, but the reason is false. Next, we'll see answer briefly. First question, define inertia, give its classification. The inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force as known as inertia. There are three types of inertia are there. One, inertia of rest, inertia of motion, inertia of direction. Second one, classify the types of force based on their application. There are two types of forces are one like parallel force, second one unlike parallel forces. Next problem of a 5 Newton and an 50 Newton forces, two forces are acting opposite to one another. Find the resultant force and the direction of action of the resultant force. For resultant, to find out resultant force, the formula is F2 minus F1. Or the second force value, F15 Newton minus first force value 5 Newton. If you eighth question, why a spanner with a long handle is preferred to tighten screws in a heavy vehicles? The answer is the turning effect of a force is called moment of a force. Moment of a force is equal to force into perpendicular distance. So the formula is moment of a force is equal to F into D. For the spanner with a long handle, D is large, therefore the moment of a force is also large, and hence it is easier to rotate the object. Ninth one, while catching a cricket ball, the fielder lowers his hands backward. Why? The answer is in cricket, a fielder pulls back his hands while catching the ball. He experiences a smaller force for a longer interval of time to catch the ball, resulting in a lesser impulse on his hands. 10th question. How does an astronaut float in a space shuttle? The answer is on the astronaut, there is no external force on him due to planet or spaceship. By the first law of motion, the acceleration on him is next we'll see answer in detail. First question. What are the types of inertia? Give an example for each type. There are three types of inertia are there. First one, inertia at rest. The resistance of a body to change its state of rest is called inertia of rest. Example for this, when you vigorously shake the branches of a tree, some of the leaves and fruits are detached and they fall down. So example for inertia of rest. Next we'll see inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. Example, an athlete runs some distance before jumping because this will help him jump longer and higher. Third, inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Example, when a bus turns towards right, the passengers are thrown towards left. Next question, describe rocket propulsion. First point, propulsion of a rocket is based on the laws of conservation of a linear momentum as well as Newton's third law of motion. Second point, rockets are filled with the fuel in the rocket propellant. Third point, when the rocket is fired, the fuel is burnt and a hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber, which makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. Next point, since there is no net external force acting on it, the linear momentum of a system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increase in velocity of the rocket. At one stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Give the applications of universal law of gravitation. Dimensions of the heavenly bodies can be measured using the gravitation law. Mass of the earth, radius of the earth, acceleration due to gravity, etc., can be calculated with a higher accuracy. It helps in discovering Students, prepare well for your exam. Write your exam well. Thank you. Have a revision on 7 book back exercise questions with answers. First one letter, choose the best answer. First question. Which of the following smallest mass? The answer is one atom of helium. Second, which of the following is a triatomic molecule? The answer is carbon dioxide. Third one, the volume occupied by 4.4 gram of CO2 at STP. What is STP? Standard temperature pressure. The answer is 2.24 liter. Fourth one, mass of 1 mole of nitrogen atom is answer 28 gram. Next, fifth one. Which of the following represents 1 AMU? What is AMU? Atomic mass unit. The answer is 1 by 12th of the mass of carbon 12 atom. Next, sixth question. Which of the following statement is incorrect? The answer is 1 mole of electrons stands for 6.023 into 10 power 23 electrons. Next, seventh one. The volume occupied by 1 mole of diatomic gas at STP is answer 22.4 liter. Eighth one. In the nucleus of 20Ca40, there are answer 20 protons and 20 neutrons. Ninth one. The gram molecular mass of oxygen molecule is dash answer 32 gram. Tenth one. 1 mole of any substance contains dash molecules. Answer 6.023 into 10 to the power 23. Next, second Roman letter, fill in the blanks. First one, atoms of different elements having dash mass number, same mass number but different atomic numbers. Different atomic numbers are called isobars. Second, atoms of different elements having same number of dash are called isotones. Answer neutrons. Third one, atoms of one element can be transmuted into atoms of other element by dash artificial transmutation. Fourth one, the sum of the numbers of protons and neutrons of an atom is called its dash mass number. Fifth one, relative atomic mass is otherwise known as dash standard atomic weight. Seventh one, of a the average atomic mass of hydrogen is dash AMU. Answer is 1.008. Next, seventh one. If a molecule is made of similar kind of atoms, then it is called dash atomic molecule. Homo atomic molecule. Eighth one. The number of atoms present in a molecule is called as dash atomicity. Ninth one. 1 mole of any gas occupies dash ml at STP 22400. Next, 10th one. Phosphorus is dash, the answer is 4. Next, Roman letter 3. Match the following. First one, 8 gram of O2. Answer is 0.25 moles. Second one, 4 gram of H2. The answer is 2 moles. Third one, 52 gram of helium. He. Answer 13 moles. Fourth one, 112 gram of N2. Answer 4 moles. Fifth one, 35.5 gram of Cl2. Answer 0.5 moles. Next, Roman letter 4. True or false? First one, two elements sometimes can form more than one compound. Answer is true. Second one, noble gases are diatomic. Answer false. More no or atomic. One. Mass of an element has no unit. Answer false. Relative atomic mass of an element has no unit. Fourth one, 1 mole of gold and silver contain same number of atoms. Answer is true. Fifth one, molar mass of CO2 is 42 gram. Answer false. 44 gram. Next, Roman letter 5, assertion and reasoning. Answer the assertion. Atomic mass of aluminum is 27. Reason. An atom of aluminum is 27 times heavier than 1 by 12th of the mass of the carbon 12 atom. Answer A and or assonant reason or does not explains A. Second one, assertion. The relative molecular mass of chlorine is 35.5 AMU. Reason. The natural abundance of chlorine isotopes are not equal. Answer. A and R are correct. R explains the A assertion. Next, Roman letter short answer questions. First question, define relative atomic mass. Answer, relative atomic mass of an element in the ratio between the average mass of its isotope to 1 by 12th part of the mass of carbon 12 atoms. It is denoted as A. It is otherwise called standard atomic weight. An is equal to average mass of the isotopes of the element divided by 1 by 12th the mass of an 1 carbon is equal to 12 atom. Second one, write the different types of isotopes of oxygen and its percentage abundance. First column, isotope. Second, mass, AMU. Third column, percentage abundance. First column, 8 oxygen, 16 mass value AMU, 15.9949, percentage abundance 99.757, 8 oxygen, second one 17, mass value 16.9991. percentage 0.038. Third one, 8 oxygen 18, mass value 17.9992, percentage abundance 0.205. Third one, define atomicity. Answer, the number of atoms present in the molecule is called its atomicity. Atomicity is equal to molecular mass divided by atomic mass. Fourth one, give any two examples for heterodiatomic molecules: HCl, H2O, water, NH4. Fifth one, what is molar volume of a gas? Answer, 1 mole of any gas occupies 22.4 liter or 22400 ml at STP. The volume occupied by 1 mole of any gas at STP is called molar volume. Next, give the sources of atomic theory. First point, an atom is no longer indivisible after the discovery of the electron, proton, and neutron. Second one, atoms of the same element may have different atomic mass. Discovery of isotopes 17Cl35, 17Cl37. Next, atoms of different elements may have same atomic masses. Discovery of isobars 20 Ar40, 20 Ca40. Next point, atoms of one element can be transmuted into atoms of other elements. In other words, atom is no longer indestructible. Discovery of artificial transmutation. Next point, atoms may not always combine in a simple whole number ratio. Example, glucose formula C6H12O6, C is to H is to O is equal, H is to O is equal to 6 is to 12 is to 6, or 1 is to 2 is to 1. And sucrose formula C12H22O11, C is to H is to O is equal to 12 is to 22 is to 11. Next, atom is the smallest particle that take part in a chemical reaction. Next, the mass of an atom can be converted into energy. Einstein equation E is equal to mc square. Next, fifth one, derive the relationship between a relative molecular mass and vapor density. Important question. A relative molecular mass, the ratio of mass of one molecule of gas or a vapor to the mass of an one atom of hydrogen. Relative molecular mass is equal to mass of one molecule of gas or vapor divided by mass of one atom of hydrogen. You take this as equation number 1. Vapor density, the ratio of mass of a certain volume of a gas or vapor to the mass of an equal volume of hydrogen, measured under the same conditions of temperature and pressure. Vapor density is equal to mass of one volume of gas or vapor divided by mass of one volume of hydrogen. You take this as equation number 2. Vapor density, you write V into D is equal to mass of one volume of gas or vapor divided by mass of one volume of hydrogen. Take this as equation number 3. Applying Avogadro's law, Vd is equal to mass of one molecule of gas or vapor divided by mass of one molecule of hydrogen. Take this as equation number 4. Hence, hydrogen is diatomic. Vapor density V is equal to mass of one molecule of gas or vapor divided by mass of one atom of hydrogen. Vapor density is equal to mass of one molecule of gas or vapor divided by 2 into mass of one atom of hydrogen. You take this as equation number 6. Multiplying 2 on both sides. Here 2 into Vd is equal to 2 into mass of one molecule of gas or vapor divided by 2 into mass of one atom of hydrogen. You take this as equation number 7. Numerator and denominator you cancel this 2. Next 2 into Vd is equal to mass of one molecule of gas or vapor divided by mass of one atom of hydrogen. You take this as equation number 8. Next 2 into vapor density is equal to this thing you write relative molecular mass. Take this as equation number 9. Vapor density Vd is equal to RMM. What is RMM? This relative molecular mass divided by 2, or you can rewrite as molecular weight divided by 2. Thank you, children.